Hi, a very good day to my lecturer, Puan Ilyana binti Ruslan. So this is our assignment for project number 1 from our subject of analog electronic devices. So before I start for our presentation, I would like to do introduction for all of my group members. So we have 3 members here. From first is NOORZILAH. Second is me, myself, Nandha. Third is POONITTHEN. So our metric number for NOORZILAH is B122410771. Myself, B122410607. And for POONITTHEN is B122410753.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nuzila binti Jamaluddin. Today I would like to present Operation Audio Amplifier. What is amplifier? Generally, amplifier is electronic device to make weak signal to be the stronger. Mostly, it's using for audio system, communication system, and various electronic devices. How it's work? Firstly, use the input devices like microphone to capture the voice and then sound wave in the vertical motion to convert in a small electrical signal. Output of microphone signal is weak, not strong energy to drive speaker directly. So amplifier used to increase the voltage of input signal become powerful energy to drive output devices effectively.
So I'll be presenting the objective part for this project. Okay, so as we know for our project, so this is our objective is to design and simulate a transistor-based audio amplifier circuit using multi-sim, and also we have did the real the prototype also we have did using the breadboard and all. So in this step you can see we use the multi-sim software to design the schematic before building it in a real life, and there is a few circuit that we have used. Later I will explain in the next part, and the simulation will allow us to check if the circuit amplifies correctly before implementing the hardware version. Okay, so the second part of the objective of this project is to study the biasing and operating point, which is Q point of a BC547 transistor. As we know, the biasing network, which is R1 and R2, ensures the transistors to stay in its active region, meaning it can amplify signal linearly without distortion. So the third part is to analyze the input and the output waveform using an oscilloscope. So we have used the oscilloscope as shown in our multisim is to visualize the input signal from the condenser mic and also output signal from the transistor's collector. So the last objective is to develop a study guide explaining how the amplifier works and how each components contribute. So as we know, here we have explained voltage gain is equals to V out equals to V in, where we can get RC over RE. So this explains, these gains tell us that how many times the input signal voltage is amplified, and also we can also verify this gain experimentally by measuring input and output voltage with an oscilloscope or a voltmeter. So the next part I'll be explaining the methodology of our project. So this is the component that we are using. We are using resistor. Okay, we are using resistor. We are using 3 types of resistor. R1 is 2.2 kilo ohm, which provide DC bias current for the condenser mic and helps to set input operating condition. R2 we use 10 kilo ohm, which provides collector to base feedback for stable transistor biasing. We use R3, which is 2 kilo ohm, to control collector current and develop the output voltage signal. The next part, we use components such as capacitor. We use 2 types of capacitor. Capacitor 1 C1 1 microfarad, and capacitor 2 is 1 microfarad. So it's actually the function of it It's also the C1's function is to passes AC audio signal into the transistor bias but blocks the DC. But output coupling capacitor is for C2, capacitor 2, the function is passes amplified AC output to the load but blocks also the DC, which it protects speaker from the DC. So the next part we use transistor type of BC57, sorry 547 BP, as you can look at the picture given here. It's the main amplifying element, increase the small input signal into a larger input signal. So the next part we use 9 volt as our the power supply supplies DC power to the amplifier circuit. So this is the next part. We use condenser mic, which converts sound into a small electrical signal, which we call it as a audio signal. So the last one we use speaker. Okay, speaker we use 8 ohm, which it will convert amplified electrical audio signal into sound signal. Okay, so that is all. So that is all for our presentation. I will pass to my next member. Thank you.
Punithen. My third matrix number is B12241075 3. So now I'm going to present about single stage audio amplifier result in multisim. The result of this project demonstrates the successful operation of a single stage audio amplifier by using a BC547 transistor in a common emitter configuration. The simulation shows that the circuit provides effective voltage amplification where the output signal has a larger amplitude than the input signal. It also confirms phase inversion with the output signal inverted by 180 degrees, meaning an increase in the input result in a decrease in the output, which is a characteristic property of a common emitter amplifier. The input and output frequency remain the same. A small input signal applied at the transistor base produces a larger charge in a collector current, which is converted into an amplifier output voltage by the collector resistor. The biasing network ensures stable and reliable operation of the transistor, and the circuit performs as intended and successfully demonstrates the principle of analog audio amplification and transistor-based electronic circuit design.
In the project, we use the battery for the source, condenser mic for input, speaker for output, and of course we use the circuit of the amplifier. In the project, we use the battery for the source. When the battery was connected, the circuit directly its function. The mic captured the voice, and the speaker start clearing sound and loudly. When the battery was connected, the circuit directly. Hi, my name is NOORZILAH binti Jamaluddin. Hi, my name is NOORZILAH.
And the conclusion is, in conclusion, the design of a single stage audio amplifier by using a BC547 transistor confirmed effective voltage application, phase inversion of the output signal, preservation of the input signal frequency, and stable operation provided by the biasing network. Overall, the circuit operates as the intended and provide a strong foundation for understanding analog audio amplification and transistor-based electronic circuit.
That's all for my presentation, and I would like to sincerely thank you for your time and attention. I hope this presentation has clearly explained the topic and achieved its objective. Thank you.